Yellowstone's supervolcano is showing signs scientists never expected. Its colossal magma chamber is swelling faster and shifting in new directions. Satellites and sensors are recording ground uplift, strange gas surges, and clusters of quakes along the caldera's northeast edge. For decades, Yellowstone was seen as stable, but now experts warn the system is behaving in ways with no modern precedent. Could America's most famous volcano be entering a dangerous new phase? And are we ready for what comes next?
Of Yellowstone National Park.
In Yellowstone National Park, geologists say one of the park's famous geyser basins now has a new hot spring.
Ian Lee is at Yellowstone, the nation's very first national park.
Capturing an eruption from the Black Diamond Pool at Yellowstone National Park.
Some warnings rise slowly from the depths, building quietly until the day they cannot be ignored. Today is one of those days. The landscape of Yellowstone, so often associated with tranquil geysers, herds of bison, and endless pine forests, now crackles with urgent anticipation. Beneath its scenic veneer, a transformation is underway. The colossal magma chamber below the Yellowstone caldera is expanding at a pace scientists did not predict, and it appears to be shifting in new directions. Rumors swirl, but the facts are stark. Amid unexpected and accelerated expansion of the Yellowstone caldera's magma reservoir, scientists with the U.S. Geological Survey and the Yellowstone Volcano Observatory are watching and analyzing with renewed focus. Sensors and satellites that have long monitored the subtle heartbeat of the park are now recording a tempo shift, ground inflation picking up, pressure mounting, and, critically, changes emerging along the caldera's northeast edge where geological data point to fresh activity beneath the surface. Across the park, through research circles as well as communities living in the shadow of Yellowstone, an air of uncertainty has taken hold. It is not a time for panic, but one for vigilance and inquiry. What does it mean when the engine room of North America's most famous supervolcano shows its power not through eruption, but through invisible and accelerated change? Are these the routine pulses of a dynamic system, or something more portentous? A signal of transition as Yellowstone's ancient legacy evolves. To understand the magnitude of Yellowstone's recent transformation, we must first look beneath the surface. The heart of the park is a magma chamber, both massive and mysterious, its presence responsible for Yellowstone's geysers and hot springs, as well as its reputation as an unpredictable force of nature. The caldera, a collapsed basin stretching roughly 30 by 45 miles, is both a marker of cataclysmic eruptions long past and a window into the living geology below. For decades, an evolving arsenal of technology, seismometers, GPS monitoring networks, and satellite-based radar, has mapped this dynamic underworld, tracking its movements with extraordinary detail. Historically, the pattern was familiar: slow swells and subsidence, with the magma chamber gently inflating and relaxing like the breath of a slumbering giant. But recently, these long-standing patterns have shown clear signs of disruption. Detailed measurements now show that inflation rates, especially near the caldera's rim, have unexpectedly increased. Where scientists would once track millimeter-scale changes as routine, they now measure several centimeters of uplift in key areas. The probable cause: magma rising and pooling beneath the caldera with greater vigor, particularly beneath the northeast edge. This is corroborated by geophysical studies, including ground deformation plots and seismic imaging, that reveal a measurable bulge in the uppermost layers of the chamber. What's especially notable this time is the gradual migration of this swelling, shifting the area of greatest concern toward the northeast. The system has always been complex, a tangle of conduits and reservoirs whose balance is anything but simple, but the current configuration, with significant and directional expansion, has no direct precedent in the recent historical record. In short, the subsurface machinery that underpins Yellowstone's landscape now appears more restless and less predictable. What's at play may be natural rebalancing within a vast and volatile system, or it may be the first visible chapter in a new episode of change. Above ground, Yellowstone's surface has begun to echo the changes deep below. The park's hydrothermal features, its geysers, springs, and fumaroles, have always provided clues to the subterranean activity. Few episodes in recent years have been as enigmatic as what is now being observed. From 2018 on, geyser activity had been frequent, but that pattern is now waning. In 2025, there have been only 2 major eruptions from renowned geysers, a marked decrease that has caught the attention of researchers. Scientists are investigating whether this decrease is simply a periodic ebb, common in Yellowstone's long variable history, or whether it is a manifestation of deeper processes, perhaps as fluids are diverted or pressurized differently due to the ongoing magma recharge. The ground itself records the system's shifting energies. Subtle warping of the land, detected by GPS and radar, has revealed tilting tree lines, altered pond basins, and discernible shifts in the contours of meadows and hot spring pools. None of this is immediately dramatic, but the consistent patterns of uplift, aligned with the northeast movement of the magmatic center, are unusual. Chemical readings offer further signals. Regularly measured gases, especially carbon dioxide, now show erratic fluctuations in both composition and concentration. Some plumes are richer in CO2, hinting at changes in degassing at depth. Simultaneously, the classic sulfur-scented vapor from hot springs sometimes sharpens, raising new questions about the chemical reactions taking place far below ground. Seismicity, too, has shifted. While minor earthquakes are common beneath Yellowstone, the seismic record lately has featured more irregular clusters and events at unusual depths. These tremors likely reflect the fracturing and readjustment of crust under the strain of new magmatic inflow. None of these phenomena, in isolation, would automatically signal crisis, yet their convergence, ground deformation, hydrothermal changes, gas anomalies, and altered seismicity all reinforce a shared narrative. Yellowstone is behaving differently than it has for many years. Among the most important discoveries from recent research is the migration of increased activity to the northeast of the caldera. Historically, hazard models have focused on long-mapped zones of concern, but satellite and seismic data now confirm that the focus of uplift and deep magmatic movement is shifting toward what was once considered a quieter part of the system. This shift is more than a scientific curiosity. It has practical consequences. Pathways for magma are not fixed. They exploit weaknesses in the Earth's crust. As magma finds new routes upward and outward, it presses against boundaries long thought reliable, lighting up fault lines and heating areas previously considered stable. Such redistribution of heat and pressure can have cascading effects. The northeast section of Yellowstone contains ecologically sensitive regions and hydrothermal features with their own complex plumbing. If new fractures or pools of magma emerge there, it could mean the rapid onset of unforeseen hazards, such as sudden hydrothermal explosions, localized ground collapse, or even the formation of new geothermal features. Recent data also suggests changes in subsurface lava flow patterns, details deciphered through changes in magnetic field measurements and subtle thermal anomalies. While these flows remain hidden deep underground, their presence is inferred from careful analysis and serves as additional evidence that the system is adjusting in new and unexpected ways. The overall picture is one of a living, reactive system. Yellowstone's volcanic machinery is not a static threat, but a constantly recalibrating engine. As magma journeys onward, models built on decades of relative predictability may now need urgent updating to contend with the fresh possibilities this shift presents. Scientists and officials are generally slow to escalate risk. For years, Even as attention was paid to minor episodes of unrest, the Yellowstone alert level remained firmly at normal, and the aviation color code was green. It takes more than isolated data points for agencies to issue a high-level warning, but recent measurements, sustained and unexpected inflation, concentrated seismic swarms near the caldera's northeast edge, and signals pointing to new magma inflow presented a pattern that could not be explained as typical background noise. Instead, these signs together raised apprehension about possible escalation. The terminology of volcanic alert levels is specific, with a red alert typically reserved for situations where an eruption is imminent or underway. While the context mentions red alert and warning language, it's important to clarify. At present, according to the official monthly updates, Yellowstone's alert level remains at normal and its aviation color code at green. However, these updates also acknowledge newly detected patterns and increased surveillance in light of the changing conditions. In parallel, the USGS and partners have activated more intensive monitoring protocols. Emergency preparedness agencies are reviewing response plans, and communications are flowing more rapidly to park managers and local authorities. This does not mean an eruption is assured or necessarily imminent. History shows that rapid inflation or clustered earthquakes can occasionally subside without further escalation. Nonetheless, the raised risk warrants public awareness and precaution. Scientific communication remains measured. Experts speak directly about the new data, its uncertainties, and the evolving risk landscape. The lesson from places like Mauna Loa, noted in context for its ongoing summit inflation, is clear. Where magma chambers fill quickly, rapid changes are possible. But each volcano is unique. An analogy only goes so far. As agencies review contingency measures and ramp up surveillance, local residents and park visitors are urged to stay informed through official channels, not rumors, and to understand that while the system is restless, its outcomes are never fully predictable. The consequences of continued, unchecked expansion in the Yellowstone magma chamber could be wide-ranging, though the precise outcome is uncertain. It's not only the threat of an apocalyptic eruption, rare as that is, but a spectrum of interconnected concerns that reach into ecology, infrastructure, hydrology, and public health. If the pattern of uplift and magmatic migration continues, several possibilities arise. In the most extreme case, a scenario for which there is no current evidence but which is always considered in risk models, the release of pressure could result in a moderate to major volcanic event. Even a small eruption or a significant hydrothermal explosion could cause localized devastation. River valleys might be blocked or rerouted, forests and meadows subjected to thermal or seismic shocks, and hydrothermal features devastated. Volcanic ash, if generated and lofted high, could disrupt regional transportation, agriculture, and water systems. On an intermediate scale, rapid inflation can destabilize ground, altering drainage patterns, damaging roads and trails, and posing localized risks of rockfall or flash flooding. Infrastructure within the park, such as lodges, roads, and communication networks, may be threatened by deformation or subsidence. If new hydrothermal features erupt in or near visitor facilities, rapid closures and evacuations could be required. Beyond Yellowstone, changes to river flows or the possibility of ashfall could affect communities and farmlands far downstream. Water quality, animal habitat, and air purity could all become matters of concern, even without a dramatic eruption. Finally, the region's vital role in tourism and recreation, serving millions of visitors annually, means even a period of heightened alert can stress evacuation routes, supply lines, and emergency response systems. It's important to emphasize, while the imagery of a massive landscape-changing eruption is dramatic, the more probable risks relate to moderate-sized events and systemic disruption. Increased monitoring and preparedness help ensure that all credible scenarios are taken seriously and that government agencies can respond quickly as circumstances evolve. Despite state-of-the-art monitoring, there are profound limits to our ability to predict precisely when or how Yellowstone's unrest will evolve. The Earth's crust, riddled with ancient faults and shifting seams, is uncooperative terrain for certainty. In scientific debates, some geologists point out that Yellowstone's history includes episodes of rapid uplift or anomalous seismicity that ultimately calmed with no significant event, a pattern seen in other caldera systems as well. Others argue that the confluence of signals now observed constitutes a unique phase, meriting increased caution and contingency planning. The difficulty is compounded by the inherent complexity of the volcanic system, a sprawling network of partially molten rock, hydrothermal fluids, and brittle crust, subject to countless variables that often defy pattern or prediction. Computer models, no matter how advanced, are only approximations of this chaotic reality. Historical analogs provide context, but not certainty. For instance, past inflation periods have sometimes resulted in nothing more than subtle landscape shifts or the emergence of new springs, while others have presaged more significant activity. The decision to raise surveillance or issue heightened alerts is therefore cautious, recognizing both the dangers of false alarms and the risks of underpreparation. Agencies communicate clearly about what is known, what remains uncertain, and what actions are prudent. In the meantime, emergency services review plans, and local communities, along with millions who visit or depend on Yellowstone, are reminded to stay informed, to trust in science, and to avoid both complacency and hysteria. Behind the statistics and models is the human dimension, the ripple of concern that runs through communities as the ground beneath them becomes the focus of global attention. Park rangers and managers double-check emergency systems and rehearse procedures developed for scenarios most hoped would only ever be theoretical. Local stores report increases in sales of essentials as residents quietly ready themselves for potential disruption. Schools share safety information. Hotels and guides keep careful track of official bulletins and maintain contact with authorities to ensure the welfare of staff and guests. The sense of uncertainty is, at times, amplified by social media and informal reports. Amid accurate updates, rumors also multiply. Wildlife retreats, strange noises, or surface cracks, some with factual basis, others purely imaginative. The challenge for scientists and officials is to keep credible information at the center of the conversation, answering public questions with transparency and humility. For the scientific community itself, this is a period of demanding engagement. Researchers must combine clarity and caution, balancing technical accuracy with accessibility for non-experts. Each update is carefully weighed, cognizant of the need to inform without inciting panic. Ultimately, Yellowstone's warnings serve as a reminder. Nature's rhythms may be beyond our command, but through collective vigilance, targeted preparedness, and coordinated response, risk can be managed if never entirely eliminated. The days since the most recent warnings began have settled into a tense present, a period in which the park's ancient heartbeat feels both more audible and more enigmatic than ever. Scientists, officials, and the public all share in the vigil, watching as new data accumulate and waiting for signs of stability or further change. No eruption has occurred. The landscape endures, swollen in places, quieter in others. Research teams deploy new sensors, collect fresh samples, and update risk models daily. For now, the immediate signs, accelerated uplift, shifting gas emissions, rerouted magmatic flow, serve as reminders that Yellowstone is a living system, always in flux. Travelers still arrive in smaller numbers, drawn by the paradoxical mix of danger and beauty. Some hope simply to experience Yellowstone's wild places, while others come out of fascination for a natural process older than humanity itself. The broader lesson is clear. To live in the proximity of a restless caldera is to accept uncertainty. Nature's timelines stretch beyond individual lives, and its changes, however closely monitored, often remain only partially understood. Yet within this challenge lies also a testament to resilience, both of the landscape, which has cycled through eruption and renewal countless times, and of the people who now prepare for all possibilities. If Yellowstone teaches anything, it is that vigilance must walk hand in hand with humility. Preparedness is not panic, and scientific caution is a strength, not a weakness. The story of Yellowstone continues to unfold, not only in data sets, but in the daily lives of those who live, work, and explore above its vibrant heart. The Earth speaks, sometimes in whispers, sometimes in urgent signals. Whether warning, reassurance, or simply mystery, these messages invite us to listen with care, long before they ever demand a more urgent response.